Hello and welcome to our CSCW 2021 presentation of our paper, An Archive of Interfaces, Exploring the Potential of Emulation for Software Research, Pedagogy, and Design. I am Dr. Eric Kaltman, Assistant Professor of Computer Science at California State University, Channel Islands.
And I'm Daniel Cardoso, Associate Professor at Carnegie Mellon in Architecture.
The study of historical software poses unique research challenges as these systems depend on networks of hardware and software systems that might be technically difficult or in some cases impossible to reproduce or reconstruct. Our paper documents how distributed emulation networks might help address these challenges and support software research, pedagogy, and design. Emulation is a type of virtualization that recreates the conditions for a piece of legacy software to operate on a modern system. We argue that it has advantages over other methods for investigating historical and sociotechnical aspects of software and software-based practices. Through a case study of a pedagogical experience incorporating emulations into a graduate course on computer-aided design, we show that emulations allow for close user-centered analyses of software systems that highlight both their historical evolution and core interaction concepts, while also revealing how they conditioned historical forms of work. We further show how emulation can be a resource in the speculative development of computational design systems.
Work leveraging historical and sociotechnical methods is relatively sparse in CSCW. However, there are notable exceptions. These include, for example, efforts to trace the evolution of computer interfaces from their 1950s origins in academic and industrial labs to realized end-user products in contemporary settings, as well as the historical development of interaction techniques. Other efforts have focused on articulating how technologies are fundamentally informed by past systems and engaged extensively with documentary and oral sources to understand their context in order to draw insight or open up pathways for design. A related but distinct strand of research informed by science and technology studies has tried to situate software in historical and social contexts in order to highlight its shaping of bureaucracies, professional practices, and public understandings, or to clarify the relationship between information infrastructures and the knowledge practices that they support, or to critically trace their ideological commitments and their linkages to emerging forms of pedagogy, activism, and labor. These examples have mostly relied on the conventional tools of historical research, oral, archival, and other documentary sources. These are, of course, invaluable to illuminate technology's contexts, but are not always well suited to examine their specific dispositions and modes of operation. A recent strand of research at the intersection of CSCW, computational design, AASI, STS, and archaeology explores an expanded methodological repertoire that engages with visual, material, and tactile aspects of historical technological artifacts, considering them as primary sources or research materials through reconstructions, restagings, or approximations of historical systems. However, while these techniques can enliven the logic of systems that depend on long-lost hardware and software, they can be methodologically impractical when dealing with more complex and more recent systems, which may be available in institutional archives and collections.
It's here that emulation can be an effective vehicle. Emulation takes advantage of existing software archival resources, offering functional access to mainstream systems. This opens up a wide space of research possibilities, including the opportunity to shift the focus away from emblematic and well-studied technologies towards what Jorgensen has called the mundane mainstream, systems that have received little scholarly attention, but are massively influential as a result of their market footprint and other factors. Emulation generally describes any method or system in which a specific computational configuration is imitating or approximating a different one. In order to provide definitional and conceptual clarity, this paper borrows its use of emulation from the software preservation and archival communities to distinguish it from a raft of other uses in computational hardware and network design. Emulation affords access to software as a primary interactive research material. By making the recovery of interactive experiences possible, emulated software offers additional forms of context that contrast not only with verbal descriptions, but also with image and video-based screen captures of software execution, as well as with the reconstructive methods previously mentioned. As we will demonstrate through emulation-based analyses of computer-aided design systems, running legacy software environments has the potential to allow for novel encounters between the user and historical modes of interaction. We introduced the Emulation as a Service infrastructure EaaSI system, a distributed emulation system that allows for web browser-based access to emulated computing environments as a pedagogical resource in a graduate level course on computer-aided design. CAD programs are professional design tools which architects, engineers, and other designers use to model the physical configuration of many artifacts. They thus play a role in structuring cooperative work in architecture, engineering, and other design fields. The course tasked students with analyzing and interpreting the history of specific CAD systems through different methods: reconstruction, emulation, and speculation. Prior to the emulation assignment, we provided a selection of historical CAD systems in the EaaSI framework obtained from the University Library and School of Architecture archives. Students were invited to research their CAD system's historical and sociotechnical contexts, as well as its visual and interactive qualities. Students had 2 weeks to familiarize themselves with the EaaSI interface and investigate their chosen CAD systems.
As illustration, we'll quickly overview the analysis of different historical versions of AutoCAD conducted by 2 students in the class. Each of them had previous professional level experience with modern versions of the software. One focused on the DOS-based AutoCAD R12 released in 1992, and the other looked into the Windows-based AutoCAD 2000 released in 1999. These were documented by the students as reflective written reports and were enriched by image captures from both their historical research and their use of emulations. The first, Josie, set out to use AutoCAD R12 and compare it with the modern versions of the software, which he knew well from his past experience. Using R12 confronted him with what seemed to be a purer and more elemental version of the system. To test it, he drew the floor plan of a simple house. He found that he had an unexpected dexterity with the old system. Finding persistent traits across old and new versions of the software, he tentatively attributed them to either the company's quote-unquote conservatism or to the existence of underlying design. We're terming this underlying design, revealed to Josie in his analysis, a software's core interaction concept. He is familiar with the repetitive nature of drafting. His discovery led him to wonder about other kinds of inputs. Drawing from his analysis, he thought of a CAD system controlled more intuitively through a user's gaze and voice. Building a prototype allowed him to analyze the potentials and challenges of these new ways of interaction and to realize that seeing is not drawing. In other words, that seeing and drawing are different and mutually supportive activities. For Jer, who like Josie was a professional architect before coming to grad school, AutoCAD 2000 seemed simple in comparison with the more recent versions. The interface was quote-unquote decluttered, the number of icons was quote-unquote manageable, and Barebone's interface highlighted for him the functional skeleton of the software for file management operations, including saving and copying drawings, managing layers, as well as associated files. He reflected on how some of these changes may have impacted issues such as the division of labor within the architectural and engineering workplaces. He drew comparisons between analog drawing practices and AutoCAD's functions. This led him to consider the different bodily postures adopted by traditional and digital draftspeople. He started to wonder how standard input devices, keyboard and mouse, shape or constrain them. With this, he imagined a speculative device to experiment with other motions and physical qualities in design work. His speculative interface comprised a tangible interface which replaced keyboard input for entering commands. With this, users could create different configurations of commands, mapping them into a different gestural and bodily vocabulary. This brief overview of our case study shows how emulations can be part of a pedagogical and research toolkit for examining historical and sociotechnical aspects of software and informing its conceptualization and design. Emulation has the potential to enliven aspects of software research and learning with an expanded context that includes phenomenal engagements with interactive systems, their time-based operation, and their visual and operational qualities.
An additional contribution is to situate emulation within a landscape of historical and interpretive methods within CSCW and adjacent fields. By helping trace a software's evolution and distinctive visual and interactive qualities, the analyses of different emulated legacy systems presented here offered a glimpse of how studies of computer-supported cooperative work might benefit from close readings of historical mainstream software interfaces and how these readings might enrich other forms of analysis and design. Thank you so much.
Thank you.